Hello fellow mechanics, we're going to talk about system to lean codes today. Before we can begin to diagnose the system, we have to understand how the system works. Understanding what is fuel trim. The engine control module looks at coolant temperature sensor, intake air temperature sensor, the engine RPM, the fuel pressure sensor, the throttle position sensor, the mass airflow sensor or the MAP sensor, and determines how long it should turn the injector on for. Then the engine control module looks at the oxygen content leftover in the exhaust system by looking at the O2 sensor reading. And if there's too much oxygen left over in the exhaust system, it will then leave the injector on for slightly longer time. You can say that the engine control module fine-tunes the air-fuel mixture looking at the oxygen sensor. If it has to make too much correction, more than 10%, it will trigger the code for system to lean.
So now that we have a basic understanding how a fuel trim system works, we can begin to do our testing to save us money and time. Verify the fault is currently there by looking at the live data on your scan tool. Make sure it is in closed loop. Look at the fuel trim. Add the short and long-term fuel trim to get the total fuel trim. If the total fuel trim is in double digits, more than 10, we have verified that the fault exists. So after verifying that the fuel trim is lean, and I'm still in the car, scanner's connected, I haven't even popped the hood open of the car yet, I would like to do everything that I need to do with the scan tool while I'm in the car with the scan tool connected. First thing I'm going to do, I'm going to compare the fuel trims at idle and at partial throttle. If the fuel trim gets worse at partial throttle, your fault is going to be in the fuel supply or a dirty mass airflow sensor. So for a fuel supply, you're going to do a fuel pressure test, a fuel volume test. It could also be your injectors. And then for a dirty mass airflow sensor, what you're going to see is at idle, your fuel trim was rich and it got worse, it got leaner as you accelerated. If your fuel trim gets better at partial throttle, suspect a vacuum leak. And if it stays the same, your fault can be in a mass airflow sensor or an oxygen sensor. To test the O2 sensor, look at the live data. If the fuel trim is lean and the downstream O2 sensor is reading rich voltage above 0.8 constantly, you have a bad upstream O2 sensor. The mass airflow sensor reading on your scan tool will be showing in grams per second. That number will be slightly higher than your engine displacement in liters. So if you got a 2.0 liter engine, expect that reading to be 2.0 to 2.2. If you got a 3.3 liter engine, expect that reading to be 3.3 to 3.5 grams per second. That would be a normal reading. If that reading is low, please check for vacuum leaks before replacing the mass airflow sensor. Smoke test your intake to see if there is any vacuum leaks from intake gasket, hoses, PCV valves, anywhere. And then when you're smoke testing the intake, the smoke will not go into the brake booster because of the one-way check valve. So disconnect the brake booster, start the car up, and make sure your fuel trim doesn't change. If it does go to normal, you got a bad brake booster. And then also don't forget to disconnect the purge valve and make sure there's no smoke coming out on the charcoal canister side of the purge valve. Fuel supply check is pretty straightforward. Do a fuel pressure test, do a fuel volume test. When you pull out the sample of the gas, let it sit for a little bit, make sure it's got no contamination in it. And that's it, guys. We got through the video. I got the PowerPoint presentation there, so you can pause, read through all of them. If you guys have any questions, please feel free to comment below, and I will respond back as soon as I can. Thank you very much for your time. Have a great day.